Okay. You guys have the sheet? I just handed it out. You need to be able to know how to use that. Gotta enjoy it. It needs to become one with you. When I taught this, anybody know Sarah Hundley? Okay, so Sarah Hundley was in my first trade class here, and I was talking with her about kind of learning the law of sines and the different situations that arise. I was like, tell me if this makes sense with you. And so I put together kind of a flow chart. She's like, that doesn't work for me. I said, okay, so I tried again. She said, that confuses me even more than the first time. So, okay. Finally, I came up with this, and she said, yep, that's perfect. So she liked that. That connected with her learning. I hope the same will go for you. So graphic organizers, some of you connect with certain ones, maybe better than others. I don't know if I've connected with. How about this? I have had some people who said that they looked at that, but it just completely confused them. But I don't think they gave it a full effort. Okay, so if you give it a full effort, I think you'll be just fine. So let's start here. Okay, back to geometry. If I have 3 angles of a triangle that are congruent to another 3 angles in another triangle, do those 2 triangles have to be congruent? No. They must be similar, but they don't have to be congruent. Look at your flow chart. If you have angle, 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 there's no solution. You can't just use the law of sines to figure out something or something like that, okay? Doesn't work, okay? How about when you were doing geometry and you came across 2 angles in a given side? Think about this. If I have 2 angles, do I then know the third angle? Yeah, because they have to sum to 180. So you really have 3 angles in a given side. Is 3 angles in a given side enough to prove congruence? Yes, and so you could go ahead and follow that path. And it says, if you're given angle, angle, side, you have one solution. Just use the law of sines and you'll find it. No problem. And you guys learned how to do all these back in geometry, right? We'll continue to practice them. What if you have angle, side, angle, where the side's in between? Is that enough to prove congruence? Yeah, again, you're going to have 3 angles because given 2, you can find the third one, and you have a side. So, again, you have one solution, use the law of sines, all is good to go. How about side, side, side? Did that work? Yeah, it did. Side, side, side worked. And we could do that, but the law of sines requires that you have a side and its opposite angle. And if you're given 3 sides, you don't have a side and its opposite angle. So you can't use the law of sines for side, side, side. You have to use something that we call the law of cosines. And we'll do that later. Side, angle, side, again, you don't have its angles and its opposite side. So again, we use the law of cosines. How about this one? When you're in geometry, what if you had side, side, angle? Did that one work? No. This one spelled donkey, right? So therefore, we said no, can't use it. Bad word. Well, the fact is that you can see that all these follow a nice box. No solution or one solution or use the law of cosines. Okay, it works out pretty well. But look at this one, side, side, angle. You have a few different options here. And you come down here, you try to identify if the opposite side is longer than the other side or not. Sometimes you could get one solution. Sometimes you could get no solution. And sometimes you could get 2 solutions. So that's what we refer to as the ambiguous case. And that's what we're going to work through today. It looks bad, but I think you're going to get it. I think we do a pretty good job of working through it together. You ready? Let's do it. If you look at your notes, I'm going to draw a triangle where we have side, side, and an angle that is not included between the 2 sides. So try to sketch this as best as you can. So if I'm given a side that's 9 and an angle that's 30, I'm going to draw another side that has a length of 7. Now, there's a reason why I draw it like that. You're going to see that in just a second. But the fact is that I, again, have a side, and an angle that's not included between the 2. We have no idea how long this bottom length is. We're not given that side. We would like to try to solve for it eventually, but we just don't know it. Watch what happens. That's one side of length 7 that I can draw. But watch what happens here. If I draw that segment, would everybody agree now that that is a triangle that has one length of 9, one length of 7, and an angle that is 30 degrees, not in between the two sides? Do you agree? Watch what happens here. Would you agree that that is still a triangle that has a length of 7 for one side, length of 9 for another, and a 30-degree angle that's not included? Do you see that? How this leg swings on a pendulum, and it can create one length of 7, and it can create another length of 7. So sometimes we have a leg opposite the given angle that is shorter than the other side. And when that happens, you might come up with two solutions. Now, we're going to go through this, and you'll understand all of it. But to just start off, I just want you to think for a second. If we were to set this up, we would say, well, I want to solve for this triangle. Okay, we'll solve for the red one. And you would say that the sine of 30 degrees divided by what side is opposite 30 degrees? 7. Equals the sine of an angle we'll call theta divided by 9. And you would go through that process of solving it. You would take 9 times the sine of 30, which is 4.5, equals 7. Whoop. 7 times the sine of theta. And you would solve for the sine of theta by dividing both sides by 7. So you get 4.5 over 7 is equal to the sine of theta. Let's just think about this. Where is sine positive? Which quadrants? 1 and 2nd. So we got 0 degrees, 90 degrees, 180 degrees. So I'm sitting right between the two there. Well, sine is positive in the first quadrant. So there's one angle right here where sine is equal to that value. There's another angle over here where sine is equal to that value. You end up with two solutions. One that's an acute angle and one that's an obtuse angle. And that's why it works. Now, right now you're saying, I don't get it at all. Okay, you will. We'll set it up and you'll solve it. But that's the idea. And that's the most confusing part that we work through. Okay? We'll show you how it works with an example. But first, let's look at another example where you could have an opposite leg that's shorter. Okay, so I'm going to draw another sketch here of a triangle. We'll draw our same one. We've got 30 degrees. We've got 9. But instead of an opposite leg of 7, I'm going to draw an opposite leg of 1. Why couldn't that form a triangle? It's too short, right? Too short. So if you have an opposite leg that's shorter than the other given side, there's a chance it might be just too short to be able to complete a triangle. And if it's too short, you'll see. Watch. We'll set it up again. Sine of 30 degrees. What's the side opposite 30? 1. Equals the sine of theta, whatever angle we're solving for, divided by 9. Sine of 30 is 0.5 times 9 is 4.5. Equals sine of theta. How do you use your calculator to solve for an angle? What do? Inverse sine. Now, think about it. We just got done testing on this. Sine of theta oscillates between what two values? What's the biggest value you can have? If you were to just graph sine of theta, what's the biggest value you can have? 1. What's the smallest value? -1. Can sine of theta ever be equal to 4.5? No. In fact, if you try it on your calculator, we'll just try it right now. If I go to my calculator, oh, if it doesn't turn on, I'm going to be mad. There it goes. Second, sine inverse of 4.5, exactly, Anna Anderson, we get an error. You can't take the inverse of 4.5. It's bigger than 1. It doesn't work. So therefore, we know in that case, we have no solution. Let's try one more before we try an example, okay? This one says opposite leg is longer. So suppose we had, 30 degrees. Let's say that that's 9. And I'm going to look at the leg opposite the angle, and we'll call it 17. If the opposite leg is longer than the other given side, then we simply have one unique solution. So those are the 3 different interesting scenarios that come up if you have side-side angle. Again, it spells donkey, right? So it's bad. And we have to, understand which of those 3 possibilities it is. If you follow the steps that I give you, you'll be in good shape, and I'll help you practice that today. Are you ready? Let's do it. Solve the following triangles. Begin by classifying which of the 5 cases it will be. Okay, let's draw it. We've got A, B, C. A is 42 degrees, B is 12, and A is 22. I set up A, B, and C. I set up A, B, and C. Angle A, 42 degrees. Side A, 22. Side B, 12. Got it. Let's figure out the rest. Let's first decide what scenario we're sitting in. Every time you set up a triangle, you should decide which of the 6. Is this angle, 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 side, side, side? What is it? It's a side, side angle. Side and an angle that's not included between the 2 sides. Do you guys understand what that means, included between the 2 sides? This one, C, would have to be given if it was included between the 2 sides. Okay? So, let's look at our chart. We've got side, side angle. Let's follow it down. It says, is the side opposite the angle longer, or is the side opposite the angle shorter? Which one is it? Yeah, if you look at your drawing, the side opposite the angle is longer than this given side. So your flow chart tells you that we have one unique solution. Just use the law of sines. So let's set it up and solve it. I could just proceed just like I would have during the last section. So we have the sine of 42 degrees divided by 22 is equal to the sine of what? Yeah, we'll just say angle B divided by 12. If I cross multiply and I go 12 sine of 42 and I divide that by 22 and I get 0.3650 equals the sine of B. Then I inverse. And on your calculator, you could just go second sine inverse of answer. And we get 21.41 degrees. Everybody good with that? Everybody see how I got that? Second negative sign. Okay, so we got 21.41. Can you now find angle C? What is it? 116.59. To find C, I use the Pythagorean theorem, right? No, why? It's not a right triangle. Can't use that. So I'm going to set up again my law of sines. I take the sine of 42 divided by 22 is equal to the sine of 116.59 divided by C. And again, we could just simply cross multiply. 22 times the sine of 116.59. And then we'll divide that by the sine of 42. 29.40. How can I check to see if my answers are reasonable? Yeah, so this is the biggest one right here is C. Well, that matches to the biggest angle. And then the middle, and then the smallest. Okay, any questions? Okay, we set up the next one. I have, let's see, A is 85. Hey, go away. There. All right. So I'm going to set this up. A, B, C. A is 85, 15, and 25. A, B, C. A, B, C. Okay, which one is this? Angle, 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 side, angle, side, side, angle. What is it? Same situation, side, side, angle. So I go to my flow chart. Is the opposite side shorter or longer than the other given side? It's shorter. So if you look on my flow chart, it says, okay, so we start here, side, side angle, we go down. Side opposite angle is longer. Nope, that was one we just had. That's one solution. Side opposite angle is shorter. Ooh, then we either have no solution or we have two solutions. Well, the only way we get started at all is to actually set up the law of sines. At this point, you got to set up the law of sines. So let's set it up. Sine of what? 85 divided by 15 is equal to the sine of B divided by 25. Very good. Do some cross multiplication. 25 sine of 85 divided by 15, 1.66. Sine of B equals 1.66. If I inverse, what happens? Yeah, you get an error. No solution. What that tells us is that 15 is too short. It's just too short to be able to reach down the other side. Yes. Because you're solving for an angle. So that's the most common mistake on this test. I don't know how many times people will get to this spot and they'll see sine of B is 1.66 and they're like, well, I already have B. It's 25. No. This is an angle. And the angle sure as heck isn't 1.66. You have to inverse sine to get rid of that. And if you inverse, you get domain error. There's no solution. Okay? All right. Well, you guys are doing really well. And I bet we have enough time to even get this part. Then you wouldn't even need to watch a video. Okay, let's draw our shape. A, B, C. 20.5, 31, 12. What do you got? Side, side angle again. Same situation. Side opposite the other given side is shorter. So therefore, we got one of two solutions. We either got one solution or two solutions. Let's set it up. Okay. I'm going to write my A, B, and C here. A equals B equals C equals A, B, C. So A is 20.5. B we don't know. We know that little a is 12, and we know little b is 31. Okay. So sine of 20.5 divided by what? 12 equals sine of what? B divided by 31. Cross multiply. (31) sine of 20.5. Make sure you're working in degrees. Divided by 12 is 0.9047. Okay, what does that mean? Look at your chart. Your chart says, when solving for the missing angle, if sine of theta is greater than 1, then there is no solution. Is sine of theta greater than 1? No. Look at your other side. When solving for the missing angle, if sine of theta is less than 1, then there are two solutions. At this point, set up two possible triangle solutions. That's what I do. Two possible triangle solutions. Triangle 1, triangle 2. These are the parts that are given, so I have to put that in there. A, B, C, A, B, C. 1.5, 12, 31. Do you guys understand what we're doing right now? Look at what we got. What we're trying to set up is the black, or I should say the blue triangle or the red triangle. There's two possibilities. The pendulum swing. We're trying to account for that. So we set up two triangles to try to account for that. Look at what we have here, you guys. This angle right here in the green. Is that acute or obtuse? Acute. So you're going to have one that's an acute angle. Look at this one right here. Is that acute or obtuse? Obtuse. So you're going to have one that's obtuse. And that's what happens. How do we figure out the acute and the obtuse? Piece of cake, upside down. We go like this. Sine of B equals 0.9047. Can somebody inverse that, see what you get? B equals what? B. You guys just want to laugh at me. I'm trying to keep Haley from falling asleep. B equals, I'm kidding. It's 64.7. Okay, so that's going to be triangle 1. That's going to be what we call my acute angle. Now I'm going to bring your brain back to something that you remember from long ago. Are you ready for this? 64.7 is what we call the reference angle. What does that mean? There's two spots where sine has a value of 0.9047. One is in the first quadrant, one is in the second quadrant. 64.7. The reference angle is the shortest angle, smallest angle between the x-axis and the terminal side of the angle. So you got one here as well. You got one in the first quadrant, you got one in the second quadrant, because that's where sine is positive. One of the angles is 64.7. The other angle is this right here. How can I figure out that blue angle? Subtract it from 180. So that's all you do. You just take whatever your reference angle was, you subtract it from 180. What's 180 minus 64.7? So that would be this one over here, 115.3 degrees. That's the obtuse one. So see, we've got an acute one, we've got an obtuse one. So So we set up our two triangles. Those are the two solutions. Can you now figure out your angle C's? Yeah, and you do each one separately. So let's focus on triangle 1. What's angle C for triangle 1? 94 point. What's angle C for number 2? 40 what? 44.2. So I've got those two different spots. How do I find angle C right here? Or side C? Law of sines. So we have to set up sine of 20.5 divided by 12 equals sine of 94.8 divided by C. I cross multiply. You guys get 34.15. And then the next one you set up the same way. Sine of 20.5 divided by 12 equals the sine of 44.2 divided by C. Somebody tell me what you got. You got 23.89. If it matches with this one, I'll give you your point back. 23.88. Sorry. I just did that to make you mad. I'm kidding. What? Somebody tell her. Not the right triangle. Got to be a right triangle. Got to have a 90-degree angle for a Pythagorean theorem to work. Excellent question. I know. We'll give Anna a break here. What do you think? All right, let's look at the last one, okay? Flip your page over just so I can see what's there. Whoa, we did some calculus there. Oh, okay, really quick, watch this. This takes no time at all. This is really good. A, B, C. You have A is 105 degrees, B is 20, and A is 4. Just think about it. Think about it. It is too small. If you have a 105-degree angle, true or false, that's going to be my biggest angle. So it also has to have the biggest side. Oh, you can see no solution right away, right? Do you guys see that? Yeah, we're done. Hold on. No, watch this last one then. It is 152 degrees. Now, you guys, you remember that with the law of sines, the reason why we're so careful about SSA is because you got to figure out where that obtuse angle is, right? Well, look, you see side-side angle. So this is another bad word problem, right? But look at it. And you're like, oh, well, the opposite side is longer than the other one. Well, that does tell you have one solution. But also, just think about it here. You have an obtuse angle, right? If you have an obtuse angle, you know the other ones are going to be acute. So can you have two solutions if you know that they're acute? No, so that's why you know right from the get-go that this is a one solution. Because if you look at your 152 degrees, If you have an obtuse angle already, then that has to be acute. And that has to be acute. That must be true. And so, there's ways that you could think about it, okay? All right, I'll put your assignment on the board. How's that? And then you have no video to watch tomorrow. You just have to work. But second hour, let's see, 6.4, page 510. Numbers 15 to 22. Wait a minute. With your last assignment, we stopped at 12, didn't we? 13. Sorry. There you go. 10 problems. That's it. You got all day tomorrow to work on. You are awesome. You can do it. Ready, set, go.